The law of conservation of matter is strict. The annihilation of the electron and the positron does not give only 2 photons. Here is why. Visible materials. The analysis of visible materials shows a common point. They all have a non-zero electrical aspect. Either their electric charge is non-zero, for example, electron. Either their electric moment is non-zero when their global electric charge is 0. For example, neutron. The existence of the electric moment induces a magnetic moment. Visible matter always breaks down into smaller electrically charged elements, or this matter is itself electrically charged. We deduce that dark matter has a 0 apparent electric charge and a 0 apparent electric moment. For example, neutrino, nu, and their apparent magnetic moment is 0. Dark matter candidate. The only possible candidate in the standard model is the neutrino, nu. The new neutrino was detected during beta decay. During this event, a collision between a proton and a neutrino took place. This collision gives rise to a mu meson and a pi meson. The equation is P plus nu gives mu minus plus pi plus plus. Photon of a proton and neutrino collision. It's Argonne National Laboratory property. You can see the proton path meets a neutrino at the head of the arrow, and the collision will give a mu meson and a pi meson. Annihilation according to SM. According to the standard model, the annihilation of an electron and a positron gives 2 photons. But this equation flagrantly violates the law of conservation of matter, because there is no experimental evidence that the charge completely vanishes. The fact that neutrino can't be seen with an instrument that doesn't measure them is insufficient evidence. The preceding photo proves that the instrument used can't see neutrino. Annihilation according to SM. Where do neutrinos come from? They are produced during beta decay. Quarks are present in atomic nuclei. Therefore, neutrinos are produced by quark decay. This also indirectly proves that quarks are not elementary particles. This is consistent with the fact that quarks are composed of 3 neutrinos. In order to satisfy the law of conservation of matter, we must add an invisible particle, but the only one possible in the Standard Model is the neutrino nu. Neutrino modeling. We deduce from this nu equal to electron minus gamma plus positron minus gamma plus. So the neutrino nu is composed of an electron having lost its main photon and a positron having lost its main photon. We know that the neutrino has a very low mass. This allows us to assume that the electron and the positron each have a residual photon. Question: how does the nu couple behave? Static or dynamic? This question will give rise to a new model of fundamental particles. Dynamic modeling of the neutrino. The electron orbits the positron and vice versa. Their trajectories form a circle of radius r. V is the tangential rotational velocity. The electric force that attracts the electron and the positron is balanced by centrifugal force. There could be different energy levels for the neutrino depending on the orbital velocity v. Orbital rotation cancels out the apparent electric field and electric moment. Dark matter is everywhere. In astronomy, it has been shown that a large amount of dark matter, more than visible matter, exists in the universe, and this matter represents a large mass. This shows that it is sensitive to gravity. The fact that these matters are invisible proves that they are in small units, less than 10 GeV. Otherwise, they could be indirectly seen by collision with visible matter. But these dark matters can cause visible interactions on low-energy particles, for example, photon and electron. It is quite reasonable to imagine that we live in an ocean of these dark matters. Creation of an electron-positron pair. According to the Standard Model, the collision of 2 photons gives an electron and a positron. But this equation flagrantly violates the law of conservation of matter. To remedy this, we must add an invisible particle, but the only one possible is the Standard Model. In the Standard Model is the neutrino nu. Because nu exists everywhere, so in laboratory, when photon enter into collision, we have a neutrino in collision too. Useful links for more details: https://nonstandardmodel.org. http://jax.dom.3.fr